Objective A. Use the formulas for squaring a binomial. The formula for squaring a binomial is written as this. Assuming we have binomial a plus b, and we are squaring this, it's simply multiplying a plus b by itself twice. So if you don't remember the formula, you could totally just use FOIL or distributive property or multiplying vertically or area model to find out what the formula is. The formula reads as you square the first term a, so a squared, and then you double the product of those two terms, plus 2ab, and then you're going to square the second term, which is plus b squared. So what happens if the second term is a negative term? That means you have another one. Another formula is a minus b squared. So if that's the case, it's the same thing, right? We square the first term, which is a squared, and then you double the product. Since the second term is negative, the product will also be negative. Therefore, it's negative 2ab. And then square the second term. The second term is negative b. If you square that, it's going to become positive b squared. Let's look at these examples. Number 1, 2 minus w squared. So remember, we have a binomial squaring. You first square the first term, which is 2 squared. And then you double the product. So plus 2 times negative w. That will be the product doubled. And then square the second term, which is negative w squared. So this is following how you get the formula. Square the first term, double the product, square the second term. Now let's calculate. 2 squared, that is 4. 2 times 2 times negative w, that's negative 4w. And then negative w squared, that's w squared. Number 3, 4x plus 3 squared. So you could just remember the same idea. Squaring the first term, 4x squared. Make sure you put grouping symbols because you have two factors in 4x and you have to square each of them. And then we're going to double the product. Plus 2 times the first term, 4x, times the second term, 3. Plus the second term squared, which is 3 squared. Now let's calculate. 4x squared, that's 16x squared. The double product, we calculate the coefficients first. 2 times 4 times 3, that is 24, so plus 24, followed by our variable x. Finally, 3 squared, that is positive 9. Number 5, 5y minus 9 squared. So same idea, square the first term, double the product of the two terms, and then square the second term. First term, 5y squared, that will give you 25y squared. 2 times 5y times negative 9, that's going to give you negative 90y. And last one, negative 9 squared, that's positive 81. Number 7, x plus 1 over 4 squared. Same idea, square the first term, x squared, double the product, so plus 2 times the first term x, times the second term, 1 over 5, and then square the second term, 1 over 5 squared. And then calculate. X squared, just x squared. 2 times x times 1 over 4, that's positive 1/2 x. 1 over 4 squared, that's 1 over 16. Number 9, negative 2u plus 3v squared. Same idea. First term squared, double the product, 2 times negative 2u times 3v, and square the second term, 3v squared. Let's calculate this. Negative 2u squared, that's 4u squared. 2 times negative 2u times 3v, that's negative 12 uv. 3v squared, that's positive 9v squared. Objective B. Use the formula for multiplying the sum and the difference of two terms. This is a very useful formula. The formula reads like this. If you have a plus b times a minus b, this product of a binomial, they look very similar. The only difference is just the sign in the middle. Then it's the same as a squared minus b squared. It's because if you use FOIL, you will find out that the middle two terms, after you simplify, will be cancelled out. They will become 0, so you simply have a squared minus b squared. Let's use this formula to quickly find out the results of number 11 and 13 without doing FOIL or other methods that you use. Number 11. First, let's rewrite this product that matches with a plus b times a minus b. Because right now, they are not exactly a plus b, a minus b. What I'm going to do is I'm going to switch these two terms. Because for addition, you could switch the two terms that you're adding without changing the final result. After we switch, you will have 11 minus 4x times 11 plus 4x. Now you see why I switch, because the resulting expression satisfies a plus b times a minus b, even though it's a minus b times a plus b in this case. But by commutative property of multiplication, it doesn't matter. Therefore, we can apply the formula. It's simply a squared minus b squared. A is 11, so it's 11 squared, minus b squared. B is 4x squared. Now let's simplify this. 11 is 121. 4x squared, that's negative 16x squared. Number 13. Number 13, good thing about this is it's already in the desired form, a minus b times a plus b. So we don't need to rewrite the original expression. We can apply the formula right away. When you apply the formula, make sure that you're going to square the first term, which is 4x. So you need to put a grouping symbol outside 4x. And then minus b squared. Our b is 3y. Put grouping symbol around 3y and then square. Let's calculate. 4x squared, that's 16x squared. You square each factor. Minus 3y squared. Square each factor, 9y squared. Number 15. 4r plus 1, 1 minus 4r. So this one is very similar to number 11, where we have to switch the order of these two terms to make it look like a plus b and a minus b. Let's switch those two. You have 1 plus 4r times 1 minus 4r. And now we could apply the formulas. A squared minus b squared. Squared the first term, that's 1 squared, minus the square of the second term. Second term, it's 4r, so make sure you put in grouping symbols and you use square. Simplify this, 1 minus 16r squared. Number 17. 6m squared times m plus 5 squared. This one is a little bit different. For this one, we have to apply the formula when you square the binomial. First factor 6m squared, I'm not going to change that. And then I'm going to apply the formula a plus b squared for this part, m plus b squared. Put a grouping symbol, and then inside, square the first term, m squared, and then double the product. So plus 2 times n times 5, and square the second term, 5 squared. So this is if I applied the formula. Now let's calculate what the inside looks like. M squared plus 2 times n times 5, that is 10n, plus 5 squared, that is 25. And that's not the end of it, because we still have grouping symbols, so you have to further simplify by distributing 6m squared. If you distribute, you will get 6m to the 4th plus 60m to the 3rd plus 150m squared. Objective C. Solve applied problems involving formulas for special products. Number 19. The area of a particular square can be modeled by the expression x minus 6 squared plus y minus 2 squared. Rewrite this expression by removing parentheses and simplify. So let's write down the expression first. X minus 6 squared plus y minus 2 squared. For each of them, we are squaring a binomial. Therefore, we just applied the formula for squaring binomials. Squaring the first term, double the product, and squaring the second term. And you're going to apply the same thing to the second square. So plus square the first term, double the product, square the second term. Now let's calculate.